Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Erfan, and I promised you before we're gonna do some past year paper questions. The topic that I've selected is cycles, or to be more specific, the cycle theorems, which we covered in previous videos. So the number of questions I have selected today for you is about 8 of them. What I suggest you to do is to pause the video each time, try to solve the questions by yourself, and then maybe you can check your answers with me. So without any further ado, let's start with question number 1. We're given a figure and told the points A, B, C, and D are points on the circle. That means the quadrilateral formed by them is a cyclic quadrilateral, right? And the opposite angles are supplementary. BCE is a straight line, all right? Angle AOC is 108 degree and angle DCE is 60 degree, as you can see on the figure. Calculate the value of W, X, and Y. I can find the value of X directly according to the angle subtended on the circumference is half of the angle subtended at the center, if you recall. So this angle, which is 360 minus 108, that gives me basically 252, right? Half of that is X, which is 126, and you might say, why half of it? So if you recall, let's do a quick recap. When I told you about this theorem, I said that the angles at the center, it's not always an acute angle, so it could be an obtuse angle. Still, this theorem is valid, meaning which if this is X, this is 2X. Also, if this is 2X, this should be X. So that's what I exactly did here. So this angle is double of this angle. Both of them are subtended by this arc. Okay, maybe that's easier to see. Then we want to find W. So X and W, since A, B, C, D, all these points lie on the circle, so we call them concyclic points, and the quadrilateral they form is called cyclic quadrilaterals. So opposite angles are supplementary, so that means W plus X must be 180. We found X, so 180 minus 126, that would be 54. Right, so W is 54, X is 126, and Y, where is Y? Y is here. We can find this angle. Since BC is a straight line, this whole angle C should be 120. 120 plus 60 is 180, right? That's the properties of a straight line. And then those are supplementary angles, therefore Y is 60, right? So each one carries 1 mark. So moving on to the next question. Question number 2, we have A, B, C, D, and E lie on the circle. Okay, they're concyclic points. So this is 140. Okay, CBF is 95. And we're asked to find X, W, and Y. You can find W right away just by looking at this cyclic quadrilateral. So W and 140 must add up to 180. W is 40 right away, 40 degree. And then what else? We have to find X, right? X plus this whole angle B, right, should add up to 180. Again, same thing, cyclic quadrilateral, but this time I'm looking at this quadrilateral. So X plus its opposite angle should add up to 180. I have the value for W. This tiny angle, I can find it because this is a straight line. The angle should be 180. 180 minus 40 minus 95. And that would give me 45, right? This is 45, and this is 40. So that adds up to 85, right? So 85 plus x must be 180. Therefore, x is 95. So x is found to be 95. How can I find y? So let me erase everything to make it more clear. I found this portion, this was 45, w was 40. So look at this arc. This arc DC is subtended by y as well as this angle. So according to angles in the same segments, y should be equal to 45 as well. I hope you still remember the theorems. If not, please go and watch the previous video about cycles. I have covered all the theorems you need to know for IGCSE, both core and extended curriculum. All right, moving on to question number 3. We are given this figure. These two lines are parallel, QR and PT. Okay, we can see that. And TP and TR are tangents, so they must have the same length. So angle PTR equals to angle RPQ. That's also mentioned on the figure. What is the special name of the triangle TPR? This is isosceles triangle. Why? Because according to the tangent theorem, this has the same length as this RT. So RT is equal to PT. Therefore, this is an isosceles triangle that only carries 1 mark. And now we have to calculate the angle PQR. What I'm going to do is, since RT, this triangle, or TPR, is isosceles, I can find these two angles, right? They have the same value. All I have to do is just subtract 38 from 180 and then divide it by 2. I get 71. So each of these angles are 71. And then, do you remember the alternate angles? If you have a pair of parallel lines and a line cutting them, so basically these two angles are equal and these two are equal. So I'm going to highlight it here. Maybe you can look at this. Okay, that means this angle should be 71, right? And the sum of internal angles of any triangle should add up to 180. And this should be 71 as well. So PQR is also an isosceles triangle. So the answer here is 71 degree. And angle PSR, now I'm going to erase everything except the angle 71 right there. Look at this cyclic quadrilateral PQRS. So in cyclic quadrilateral, opposite angles are supplementary. So I need another 109, which gives me 180 with 71 right there. So that's the answer. All right. It only carries 1 mark. And moving on to next question. We're given a figure. We're asked to find PQR. And tangents, yeah, these two lines are tangent to the circle. So let's find P just by looking at the figure. This is a cyclic quadrilateral. So P plus 126 must give us 180. And that means P is 54, right? So P is 54. Q can be found by subtracting 75 and 54 from it. And that means 51, right? So Q is 51. And then if you look at this triangle, because from an external point, from a point outside a circle, when you draw the two tangents, that forms a triangle like this, which is an isosceles triangle because the lengths of those two tangents are equal. So it means if this is 51, this should be 51, right? That's an isosceles triangle. So therefore, R is 78, right? 180. minus 51, that gives us 78, and that's it. We found all the unknowns. So moving on to the next question, question number 5. TA is tangent at A to the circle center, angle OAB is 50. Z can be found right away because the angle that the tangent makes with the radius at the point of contact is 90 degree, right? This should be 90, therefore Z is 90 minus 50, which is 40. So this is 40. And let's find Y. So don't look at the bigger triangle because T is also an unknown. That doesn't really help much. However, if you look at these smaller triangles, this is an isosceles triangle. Why? Because two of its sides basically are the radii of this circle. So that makes it an isosceles triangle. So if that's isosceles, this should be 50. And then Y can be found by subtracting the value of these two angles by 180. Both of them add up to 100. So 180 minus 100, that's 80. Now T can be found easily. Just look at the bigger triangle now. The bigger triangle is this guy right here. That's a right angle triangle. This is 90. Y is 80. So T is 10. Right? You add all of them together, you get 180. So T is 10. That takes care of question number 5. Question number 6. Okay, that's a very huge circle. The diagram shows a circle center O. A, B, and C are points on the circumference. OC is parallel to AB. Okay, if that's parallel, means this angle, look at this. This should be 25.2, right? So that's immediately what we can conclude. Again, alternate angles, right? So this should be equal to this. Calculate OBC. If you look at the triangle OBC, that's an isosceles triangle, right? So if I find just the angle COB, then these two angles have the same value. So OBC is equal to OCB2, right? So how am I gonna find the angle COB here? Well, it's very easy. Look at the arc opposite to angle A. So these two angles, both of them are subtended by the same arc BC, right? This angle and this angle. The difference is one of them is located on the circumference, the other one is located at the center. And then, according to the theorem, the one at the center, its value or its magnitude is double of the one located on the circumference. Therefore, this should be 50. So if this is 50, and according to what I just said earlier, which was the triangle BOC is an isosceles triangle. Each one of them should be basically 65, right? 65 and 65, that's 130 with 50, 180. So the angle OBC is 65, right? 65. And let's go even a little bit further. If they wanted us to find this angle, what would you do? You have to find this, right? And double that to get this. And I know this is 65 already, the whole thing. And you subtract 25 from it, you get just to practice this theorem. That's a very famous theorem. So question number 7. Okay, we're given a circle that's a lot of points there and lines, many of which is just there to confuse us, right? Find W, X, Y, Z. Look at the order. There is a reason they gave you in this specific order. Basically, it means it's like solving a puzzle. If you find W, then basically X and then Y and then Z, they will kind of reveal themselves to you. So at first glance, there is no clue, right? maybe you say, okay, X is 22, right? That's the first thing that many students, they can find because it's the same arc, right? Subtended by the same arc. So these two angles are equal. So we found X first, which is 22. But how about W? Well, let me erase this part and draw your attention to this triangle. And bear in mind that AD is basically the diameter. So if AD is the diameter, if you remember the theorem, it was saying angles at the semicircle. So these are all 90 degree if AD is the diameter. So this is 90 degree. If this is 90 degree and if this is 60, therefore W should be 30, right? So W is 30, X is 22. I explained you why. And now let's make use of the parallel lines, right? It was given to us for a reason. This whole angle, if W is 30, this whole angle is 52. And then take a look at this part, okay? So again, the properties from the number line, these two angles are basically alternate angles, and Z should be 52 as well. Let me write that here. And then take a look at Y. It's subtended by the same arc as W. So W and Y have the same value, right? According to the same segment theorem. That means if W is 30, Y should be 30 as well. So I'm going to write that here. Y is 30. And that's it. Those are the answer. W and X, Y and Z. All right. The last question. Okay, we have a tangent ST touches the circle at point C. I think it's very clear. The first thing they ask us, which carries 1 mark, very easy. ABCD is what type of a quadrilateral? Well, since all the points lie on the circumference of this circle, we call this cyclic quadrilateral, right? And second part, find the value of X, Y, Z. Okay, I can find X immediately. Just look at these two parallel lines and the line which cuts it. So therefore, according to alternate angles, X should be 40. These two angles are equal. So X is 40. And then look at Y, look at this triangle. That's an isosceles triangle because these two sides are basically the radii of the circle, right? So if this is Y, this should be Y2. They both have the same value. So 180 minus 130, 50, divide by 2. This is 25 and this is 25. So Y is 25. And let's find Z right there. Then look at the cyclic quadrilateral. Opposite angles are supplementary. This angle is X plus Y, right? That gives us 65. And Z is basically 180 minus 65, which is 115. So, okay, degree. And moving on to the next part, let's see what they're asking us. Write down the value of angle OCT. So that means we're gonna draw a line from the center to C. You shouldn't trust the scale, okay? That means don't really rely on your eyes this time. We need some facts. If you remember when I explained to you the properties of the tangent, I said the tangents at the point of contact, it always makes 90-degree angle with radius, right? So this is 90 degree. So without even thinking immediately, you should know that this is 90 degree. Afterwards, it only carries 1 mark. It shouldn't be that hard. And then find the value of the reflex angle AOC. So AOC, there are basically 2 angles. They want the reflex one. So this is one, and this is 1. So reflex, you know, it means more than 180, right? So I know the value of Z, right? This is 115. Therefore, this guy, maybe I can use another color, the blue one. If this is 115, again, according to the theorem that says the angle at the center is double of the one on the circumference. So this should be 230, right? That's 230, and 360 minus 230, that means this is 130, sorry. That should be 130. They add up to 360. So which one is reflex? This is obtuse. The green one is obtuse. The blue one is reflex, right? Because they say angle AOC. If you look at AOC, there are two ways you can look at this. There are two angles basically formed. So the reflex one is 230. That's what they asked, right? They even highlighted it for us. Having said that, that was the last question. I hope you have enjoyed the video, and I will see you guys in the future videos. Thank you very much and stay safe.